Welcome back. Let's continue. Day 19, electrostatics and electric circuit questions coming now. So what are we doing? We are giving you 30 seconds for each question to try, and we are showing our correct answers. All right, let's start. Your first question, Coulomb's law in words. Before reading all questions, all details, number 1, question 7.1. Coulomb's law in words. Please try. Don't forget to get your exam pad and write it down. And when you are getting answers, please mark your paper. Let's use this way to make it easy for you. Coulomb's law in words. Today's topic is electrostatics. Coulomb's law. Yes, 5 seconds now. Please try, write it down, please. Not just say Coulomb's law is this, please write it down, and then you can check your answer, you can mark, maybe red pen you can have just to correct your answers. All right, Coulomb's law, the magnitude of electrostatic force between two charges, Q1 and Q2, directly proportional to the product of magnitudes of charge and inversely proportional to square of the distance between them. That's it. This is our Coulomb's law. I will just keep a few more seconds. You can write it down or you can just check. Coulomb's law in words, you should write like this. All right, now let's see what they are asking. So now they said, you have two objects, negative Q and negative Q, with distance x. And then your force, electrostatic force between these two is 1,984 newtons. If you take them away from each other, x plus 0.8 meters. Now, mean force is 124 newtons. And then asking you calculate initial distance. X, how many meters? Okay, you have 30 seconds now. I will keep quiet. You are gonna try. Good luck. We are using Newton's, Coulomb's law. Sorry, we are using Coulomb's law. If you need extra time, please stop video and then carry on. All right. So how we are gonna answer this question? Number 1, for first position, writing our formula, F net equals K times Q1 times Q2 over R square. So, but if you want to show on the negative repel each other, this way we have electrostatic force. This other side also electrostatic force. And we know for first position, force is 1,984. This is our step 1. As you see, I'm just writing Coulomb's law for first position, Q1 times Q2, both of them Q, so Q square over X square. So next position, now you have F equals same formula I'm using. Now F is 124. K times Q1 times Q2 making Q square, and then X plus 0.8, because this is my new distance. I'm using these two equations and then getting X. How we are getting it? Maybe you can use this way. If you make cross multiplication here, you can say K times Q square is equal to 1,984 times X to make it easy. So you can use this one here. Let's write 1984x squared. After that, you just calculate this one, cross multiplication, doing a long process. So finally, you can get your x from now, it is maths, you can calculate. So you are getting x from this equation. You can use other options, of course, other easy ways. If you remember, you can use it, but you are getting x first. This is our question 7.2. 7.3, now, calculate the magnitude of charges. So it is easy to calculate now because you know force, you know distance, you are looking for charge. Good luck. Using Coulomb's law one more time. Coulomb's law one more time. Please try. You can use first position or second position. It's up to you. Which one is easy for you to calculate charges? Okay, time is over. So let's show our answer now. So using same formula, now you know already force and you know charge, you know distance 0.27 using first equation or second one, and then you are getting charge of object. That's it. So using this one, if you need extra time to check, you can check here. So this is our answer for 7.3. 7.4. Now you are busy with electric field, not electrostatic force anymore, electric field. For now, 7.4.1. What's going on now? You are taking this first position and adding a proton at point P. Okay, what is charge of proton? Positive, right? So we know positive. So proton is attracting by negative Q and attracting by another negative Q. Remember that. So define electric field. Okay, first one definition. Just try. What was the electric field? Electric field, please try. Today we are answering two questions, questions 7 and 8 from our past paper. And then other video, we are learning question 9 and 10. And then I'm trying to make 20 daily questions, 20 days. After that, we can start new past paper with 21. And then from 21 to 30, another past paper. Just like that, we'll carry on. All right. So electric field definition is coming now. Definition is here. Please study electrostatic force experience per unit positive charge placed at that point. All right, this is our definition. Please mark your paper. Just check your answer first. Okay, electric field definition done. So in this topic, electrostatics, they can ask you Coulomb's law or electric fields. They ask both of them in this past paper. So let's continue. Next one, net electric field at point P. So you're not busy with proton. You are busy just at point without charge. All right, because electric field only needs one charge, negative Q here, and another electric field, another charge, but one for each. All right, 30 minutes you have. We are looking for net electric field at point P without proton. So electric fields at point P. You should just remember electric field formula. Maybe you can keep your formula box with you, all formulas, formula box, and then it's going to be much easier and constant numbers, everything. You can keep it with you when you are busy with our lesson. All right. So net electric field we are calculating, guys. So E equals E K times Q over R squared. This is, okay, let's show on the diagram. So this is first one, right? Yeah. First one, E1. So negative and positive, negative. Oh, sorry, we are not using proton, we said for now. Electric field, we are busy with electric field. For electric field, if you have negative always attracts. Okay. If you have negative charge, just you have 1 point this side, 1 point this side, 1 point this side. Let's show like this. So always attracting them all. Okay. So remember that. So if you have one charge here, Q, negative Q, and then you have point that side, direction of electric field this way. This is 1P. All right. And then next one, also negative, so also attracting. That one also attracting. This is another electric field, but it is shorter than that because distance, long distance, getting less electric field. This is E to P. All right, both of them same direction. So what we are going to do, we are going to calculate and add them. See, firstly, K is 9 times 10 to the power of 9. Q we calculate already, and distance is 0.4. As you see, first charge and point distance is 0.4, and calculating. Unit is N per coulomb. Newtons per coulomb. Another formula is force over. Okay, just we can use that one, force over charge. Okay, so next one, same calculation, but now you have X, we know already it was 0.27, total is 0.67, 0.4 plus 0.7, you total distance from point P to this charge. You are calculating them and adding them, and direction also we should write, don't forget, direction, this did, because they didn't magnitude. Oh, direction we don't need, because they said magnitude of. All right, in memo they gave, but we don't have to write, because they said magnitude of electric fields. All right, so we have done our electric fields. I hope everything is clear. Everything is just using this formula and calculating. Remember, negative always attracting. If you have positive here, just let's say, if you have positive, what's going to happen? Just always repel. Okay, well, repel, and then other one is negative. Let's say attract, so subtract from each other if you have that kind of question. Okay, we have done for 2. Let's continue with next one. Now, they're asking you net force by the proton at P. Okay, so now you don't have just points, you have proton. All right, you have proton, you are just using that proton. So what you are going to do, the electrostatic force between this negative Q and proton. Proton is charge is 1.6 times 10 to the power of negative 19. Remember that, let's write it here. 1.6 times 10 to the power of negative 19 coulombs. This is charge of electron, just like charge of electron, but positive. All right, so charge of proton. Proton, charge of QP, we can write maybe. So charge of proton is here. So we are looking for electrostatic force. Same steps, but only with Q1 and Q2 formula. Negative, then this is positive, so we'll attract. So other one also attracting. So, and then you are adding long process, or you can use another options. Okay, please try. Your turn now. It is last one from question 7, but today we are going to try to answer question 8 also, because I want to complete this past paper with video 20. After that, for each past paper, we are going to use 10 different video lessons. All right, please try. We are looking for net electrostatic force, not field anymore. Force, we are going to calculate. Time's up. All right, let's continue. Now, first option, you remember we said force over charge. You can use this way. So we are looking for net electrostatic force. You know already the net electric field. If you know net electric field, easy to calculate net electrostatic force. This is your first option. All right, negative, just positive mark, because we are using that electric field from that question. Option 2, long way. So you are calculating F1, FQ1 attracting this way, FQ1, and the other one is FQ2. As you see, they have same direction. You are calculating by using this formula, and then you are getting F net. You are just adding them. All right, so this is our solution for this question. Question 7 we have done. Let's continue with question 8. Question 8, electric circuit questions. So we are going to work on it. We are going to read question, everything, but please try to write EMF in words. Okay, in 30 seconds, please try what is EMF. In this question definition, as you see, all questions coming with definition first and then other calculations. Okay, please try. You have one question asking you what is EMF. Definition, let's give. To make sure you are getting good mark for definitions, maybe you can get your list, write it down always, try always and check it. Okay, you can use that way. Okay, the EMF is coming now. This is our EMF definition, maximum energy provided by a battery per unit charge passing through. This is our definition for EMF. Okay, please check your answer first. Okay, so trying is key, right? For success, please remember that. Let's continue. Now, let's see what they're asking. Okay, we have two experiments. First one with parallel combination and another one, the different combination we have, different connection we have. Both of them including internal resistance, EMF, switch is closed, ammeter we have. For this one, we have voltmeter. Other one also we have voltmeter, but other side. Okay, and ammeter reading is given, current, main current and voltage for voltmeters given. Okay. They ask you to calculate EMF. How can we calculate EMF? Okay, please try. EMF of the battery now. We are busy with EMF of the battery. This question maybe will take time. Five seconds left. Please try. Okay, so calculate the EMF of the battery. We are going to calculate. Let's check how we are going to calculate. We are using these two experiments using EMF equals current times in external resistance plus internal resistance. This formula we are using because we know EMF equals V external plus V lost. V external is I times R. This R is total R, and plus V lost is equal to I times R. And then you can write this one here, I times R plus R, giving you that. And I know from this one, for experiment one, okay, experiment one, current is 6, okay, how they are writing 18.6. Okay, let's explain that. So let's start over. Okay, EMF is equal to, if you just say this, I times R plus I times R. So I times R, what we know, V external, voltmeter, already given 18 points. V external plus I times R. V lost, I'm still keeping like this. And then for the external, I know 18.40 from table, it's here. And plus I is 6,13 times internal resistance. This is my first equation. I'm going to keep it. And then I will write for experiment 2. For experiment 2, same steps. I times R plus I times R. I times R is V external. V external is 20,58. It's here. Plus current is 178. I'm using that current times R. From now, you are using these two equations. They are just, you can say they are equal. Okay, let's write, because both of them equal to EMF. So you can write 18.40 plus 613 R equals 20 plus 58 plus 178 R. From now, R is going other side, is going other side, and you can calculate internal resistance. That's it. And then when you get internal resistance, you can use this one or this one, it's fine. So this one, so you can get EMF. So using second one, okay, 20,58, current times 0,5, and then you are getting EMF. All right, using this way for this question, using internal resistance and external resistance and EMF formula. Okay, we have done. Let's continue with next one. Calculate the resistance. Now it is easy. Just remember this equation. Let's go back. Now you know EMF. Let's show. Now you know EMF and you know current already. You know internal resistance. One only are external. It is not given, so you can calculate it. Please try. Let's give your 30 seconds to try. Okay, calculate the resistance of R. What is our resistance R? Remember, when you calculate R with that formula, you are getting external resistance. Okay, total resistance. Still, you should calculate not just this R. All right, just remember that. That is R external. We are calculating R external. Yes, time's up. So let's continue. Now let's see how we are going to calculate. You can use experiment 1 or experiment 2. It's up to you. Let's start with experiment 2. This is our formula. EMF we calculate already in other question. Currents we know already. From table you are getting it. This experiment 2, current is here. EMF we calculate already. R plus 0.5. And then you are getting R. But this is not our final answer. Please don't do that mistake. It's not our final answer. Now I'm using experiment 2, right? So R total equals R1 plus R2. And I know R1 and R2, they are equal. Maybe you should say R external, and then you just separate, or RS we can use. So you are getting resistance option 1. Option 2, using other experiments, same steps. So using R parallel combination. Now let's say R parallel. So R parallel you calculate. After that, 1 over R1, 1 over R2, R1 and R2, they are equal. Finally, you are getting R 6 ohms. As you see, 5.78 and 6 ohms plus minus same. So when you round off, you are getting it. Well, because of calculation, just a bit different because you are okay, because of experiment. Maybe. So, and then other options, you have other options. V external is equal for experiment 2. V external is equal to 20, and then I times R external. You are calculating. This is for experiment R external 1 times, oh, 2R straight. Okay, because I'm lost. What's going on here? So for R external, straight writing R plus R, 2R. Straight using 2R and then getting answer here. Okay, another one, same steps. Now R over 2. Because R external is R over 2 and then getting R. All right, so we have done this question also. Let's continue with next one. Let's see what they are asking. Now, experiment 1 is now disconnected. Okay, one resistor of, okay, one of the resistors in experiment 1 is now disconnected. Okay, it means you remove one resistor from parallel combination. Okay, so how will this effective power? How effective power? So what's going to happen? Please try. You are going to say increase, decrease, or remain the same and explain it. Please try. For experiment 1, you remove one resistor. If you remove one resistor, what's going to happen? What will happen to your power? Power by the battery. Okay. Power by the battery. That's our question. Please try. Don't forget to try, guys. All right. Always we should try. Write it down. Do you know in physics there's no another option? You should have practice. Okay. So let's see our answer now. Answer is decrease. Why decrease? Because if you remove R1, just one resistor from circuit X, it means experiment 1, total resistance will increase. Total resistance will increase. We know that because in parallel, just let's give it examples. If you have 10 ohms for each, 10 ohms for each in parallel combination, and for now, what is your total resistance? 1 over 10 plus 1 over 10 are parallel, or straight, you know already half. So 2 over 10 equals 1 over 5. So your total resistance is 5 for now. All right, but if you remove 1, what's going to happen? If you remove 1, this is gone. What is left? Only 10 ohms left. As you see, total resistance increase. If total resistance increase, a constant EMF, so P equals V square over R, because power is equal to V square over R. We know that, right? Power is equal to I times V, and then from here you can write I is equal to V over R. You know that, V over R times V, and then you can get this formula. So if R increase, power will decrease. All right, so just using this method to get answer. Okay, Next question. It is, I think, last one. Yeah, today's last question. We have current 4.4A for, okay, an oven of resistance is 50 ohms. Calculate the cost of electricity by using 6 hours. Price is given with rent, South African rent, you know that. So let's try. Let's give your time, how much you are gonna pay. Per kilowatt hour, 1.69 you are paying. So what is your cost for this? We should calculate power first, and then using, in memorandum, I can show memo, but if I just write it down, all answers is much better for you. This one here, complicated, looks complicated. Okay, make it easy for you. So, cost of electricity, cost equals power rating times unit price. I'm using this formula to calculate cost of electricity by using 6 hours. So, first of all, time, it's supposed to be in hours. Yes, it is here. So 6 hours. This one, I can just write it here. On the question paper, you can write like this, but when you start answering formula, everything you should write. And unit price with rent or rent, whatever you have in, yes, unit price also given. Now I need power. Power in kilowatts I need, all right. So power is supposed to be in kilowatts. Okay, so let's remember power equals current times voltage. But I don't know about voltage, but I know current, I know resistance. So for voltage, from Ohm's law, I know voltage is equal to I times R, right? So I can write for V, I times R. So I square times R. So this is my power. Power equals I square times R. All right. But when you calculate this, it's going to be in watts. To get in kilowatt, what I need, divide by 1,000. Okay. So now I know I know R, and 1,000 divided by 1,000 because I'm trying to calculate in kilowatt. So now I can show that solution to you. Now you will see it's going to be easy. Yes, now let's show that we can clear all. Yes, so cost of electricity, power is equal to I square times R times time. Straight there, just as formula box, they are using, I think we just, no, they mix them all. Let's go back, it's much better. Okay, this definition, it's much better like this. Okay, even now we are going to confuse. So I square times R over 1,000. So cost equals power rating is I square times R over 1,000. Why 1,000? You understand, right? From watt to kilowatt. When you calculate with I square times R, so you are getting in watt. So times 6 times 1.69. Okay, this calculation. After that, cost equals current is 1.4 times resistance is 50 over 1,000 times 6 times 1.69. And then when you calculate this all, you can get your answer. Okay, we have done for now, for today. Yes, and then when you calculate them all, answer is 9.82. We have different options, but this option is best one. Which one? Yeah, this option is best one, easy way, because cost equals power times time times unit, and power rating in kilowatt. You are calculating power by using this formula and then calculating it. So let's show other options also to you. So other options, just mixing them, doing something else. Other options also correct, of course. Which one is easy for you, you can use. All right, thank you very much. We have done for today. So see you next lesson. Day 20, coming. When you go to day 20, you are going to see electrodynamics and photoelectric effect. Last 2 questions from this past paper. Please come with your exam pad and with your formula box. All right. To make it easy for you to try to test yourself, please do that. Thank you very much. See you next lesson.